Okay, imagine your body as a really smart home.
Yeah.
Your immune system. Think of it like the ultimate security setup.
Right.
Like a super sensitive smoke alarm combined with a highly trained fire brigade.
A good analogy.
So when there's a real emergency, maybe a deep cut, some virus trying to invade, or even a cell going rogue, that alarm just blares.
Mm-hmm.
The crew rushes in, they deal with the fire, clean up the mess, and then this is the crucial part. They stand down.
To go back to the station.
Exactly. Back to the station, ready for the next real call. That's how it should work.
That's the ideal, yeah.
But what if, as the years go by, that smoke alarm starts getting a little, twitchy?
Right, oversensitive.
Yeah, and starts wailing at just a whiff of burnt toast, maybe even when there's no smoke at all.
Yeah.
And the fire crew, you're kind of constantly on edge.
Always milling about.
Running around the house, maybe spraying a bit of foam here and there, creating this low-level chaos, even with no actual fire.
That constant low-grade internal alert.
Yes. That's what scientists are calling inflammaging. This chronic inflammation that gets more common as we age.
And it's surprisingly damaging. Quietly, but significantly.
Especially, it turns out, for your heart. So on this deep dive, that's our mission.
Yeah.
Was peel back the layers on this silent process.
Understand what it is, how it impacts the heart.
And Ben, maybe the most exciting part, look at the cutting-edge science that's offering genuinely new ways to, cool these hidden fires.
Absolutely. Though it's really important to start by saying inflammation itself, it isn't the bad guy here, not inherently.
Right, we need it sometimes.
We absolutely need it. It's vital for survival. Think about it. It's what heals a scraped knee, right?
Mm-hmm.
It fights off colds, the flu. It's essential for cleaning up damaged cells after any kind of injury. That immediate controlled inflammation is good. It keeps us healthy.
Okay, so that's the friend, the hero even. But what flips the switch? How does it go from that helpful acute response to this inflammaging thing? Where does it go wrong?
That's the key question. And the shift seems to happen with age, primarily because the immune system's on switch, it stays pretty effective.
Still works fine.
But the off switch, that starts to falter. It gets less reliable.
Ah, so it's like the signal to deploy the fire brigade is always loud and clear.
Yep.
But the signal telling them, okay, job done, go home now, that gets weak.
Precisely. They just linger. What seems to happen is that our adaptive immunity, that's the really specific part, the memory-based immune cells like the special forces.
The ones that remember past infection.
Exactly. That part tends to slow down a bit with age. But meanwhile, other parts of our innate immunity, the more general first responders.
Like the general patrol cops.
Sort of, yes. They can become overactive. They start churning out these chemical signals, things like IL-6 and TNF-alpha. Think of these as the loudest, most persistent alarm bells.
Okay.
And they're ringing even when there's no real emergency. And kind of paradoxically, other innate defenses, like the neutrophils that are meant to be precise cleanup crews, they actually decline in function.
So it's all out of balance.
Totally. You end up with this imbalanced immune system, creating this constant low-level hum of inflammation that just never really shuts off.
Okay, that paints a really clear picture of the immune system getting, out of whack. And this constant chatter, this immune noise you mentioned, it's not just background static, is it? It's actually doing damage.
Yeah.
Especially to the heart. How?
Yes, it's actively harmful. This constant inflammatory state gradually, almost sneakily, injures the delicate inner lining of your blood vessels. We call that the endothelium.
The lining inside the arteries.
Exactly. And think of these tiny spots of injury like little sticky patches.
Okay.
They become gathering points for cholesterol, for immune cells, and over time, this leads to the buildup of fatty plaques. Atherosclerosis.
Right, the classic plaque buildup.
But here's where the inflammation becomes especially dangerous. Those inflammatory chemicals, they actually weaken the protective caps on these plaques.
Making them unstable.
Highly unstable. Making them prone to rupture, to breaking open. And if a plaque bursts, that triggers a blood clot right there.
And that's the heart attack.
Or the stroke.
That's exactly the event.
Yeah.
So it's not just the plaque being there, it's the inflammation making it fragile. A ticking time bomb, as you said.
Wow. Does it stop there? Or does this chronic inflammation mess with the heart in other ways too? Maybe beyond just the plaques in the vessels.
Oh, it definitely doesn't stop with the plaques. Beyond making them unstable, inflammaging can also contribute to the stiffening of the heart muscle itself.
Affecting how it pumps.
Yes, and disrupting its natural rhythm, potentially leading to arrhythmias. It can even impair how well the heart recovers after a heart attack, which can cause longer-term problems like heart failure.
So it's quite pervasive then.
It really is. if you think about that old plumbing analogy again, a few rusty spots might be okay for a while.
But over decades, that constant corrosion weakens the whole system. And then one sudden break, one blockage can cause a catastrophic flood. That's kind of the long-term effect of this simmering inflammation on your heart.
You know, for so long, it felt like cardiology was all about cholesterol and blood pressure, hammering those numbers down, which obviously are still critical.
Absolutely crucial, foundational.
But what you're describing is this other layer. Even if you get your cholesterol perfect, your blood pressure spot on, there can still be this silent fire burning away, this residual inflammatory risk. That feels like a huge shift in thinking about heart health, isn't it?
It really is a major shift. It's recognizing that inflammation isn't just a bystander, it's an active player. Even when those traditional risk factors are well controlled, inflammation can still pose a significant independent threat.
And that understanding, I guess, opens up the possibility for completely new types of treatments.
Exactly. Therapies that specifically target that remaining risk. It's forcing a reevaluation of what truly constitutes comprehensive heart protection.
And the really encouraging thing is that some of these aren't just theoretical. Some are actually being used now.
Yes, which is fantastic. We have tools available right now. Take low-dose colchicine.
The gout drug.
Historically, yes. But now it's used in a tiny daily dose, specifically shown to reduce recurrent heart events.
How does it work in this context?
Well, it seems to calm down those over-enthusiastic immune cells within the plaques themselves, sort of diffusing them from the inside.
Interesting. What else?
Then you have the GLP-1 medicines, things like semaglutide.
Oh, the weight loss and diabetes drugs everyone's talking about?
The very same. But beyond weight loss and blood sugar, they've shown this remarkable ability to cut the risk of heart attack and stroke. And part of that benefit seems to come from reducing inflammation.
How so?
Particularly inflammation linked to visceral fat, that deep abdominal fat, which is known to be a major source of inflammatory signals. So it tackles that source.
Fascinating. Like an anti-inflammatory bonus effect. Okay, so that's what's available now. What's further down the pipeline? Late-stage trials, maybe?
Yeah, there's some really exciting stuff coming. We're seeing drugs specifically targeting key inflammatory signals. For instance, IL-6 blockers.
Ah, IL-6. That loud alarm bell you mentioned earlier.
Precisely. Drugs like ziltivekimab and pacibartug are basically designed as a very precise mute button just for that IL-6 signal. They're in large outcome trials right now.
Okay.
Then there are the LPA gene silencers, things like lepglycerin, olpasiran. These are really quite revolutionary.
Gene silencers, how does that work?
They essentially tell your body's machinery not to produce so much LPA, which is a specific type of cholesterol-carrying particle. It's known to be particularly sticky and inflammatory when it builds up in blood vessel walls.
So stopping the problem at the source before that inflammatory particle even gets made in large amounts.
Exactly. It's a very targeted approach.
And then, maybe even further out, looking really cutting edge, are there things being explored that might be considered more like truly anti-inflammaging therapies, hitting the aging process itself?
Yes, that's where it gets potentially transformative. We're looking at things like senolytics.
The zombie cell killers.
Yes, that's the nickname. Drugs designed to selectively find and clear out these old senescent cells.
Because they're the ones pumping out inflammatory stuff.
Exactly. They're like little inflammation factories that just won't quit. Clearing them out could potentially lower that background inflammatory noise significantly.
Okay. What else?
Then there are pro-resolving molecules. These are compounds that don't just block inflammation, but actively help the immune system's off switch to work better.
Ah, helping the clean up and stand down process.
Precisely. Ensuring inflammation resolves cleanly, like it's supposed to, instead of just simmering on. And finally, things like mTOR inhibitors.
That sounds familiar, related to aging research.
Yes, they're involved in nutrient sensing and seem to influence immune balance. They've shown some really interesting promise in animal studies for slowing down multiple aspects of aging, including inflammation. But it's really important to stress.
Still early days for humans.
Very much so. Largely unproven in large-scale human trials for this purpose yet. Lots of potential, but still experimental for anti-inflammaging.
Wow, okay. That's a glimpse into a potentially very different future for managing heart health and aging. But it also sounds like we don't just have to sit around and wait for these drugs. There are things we can do now, right?
Oh, absolutely. We are definitely not powerless while the science advances. Many of the lifestyle choices you make every single day can have a direct impact on dampening chronic inflammation.
Keeping that immune system less twitchy.
Exactly. It's about proactive maintenance.
So are we talking about the usual suspects, like eat a rainbow of fruits and vegetables?
That's a big part of it, yes. Focusing on fruits, vegetables, nuts, oily fish, whole grains, they're packed with anti-inflammatory compounds. Plus, and this is key, they feed a healthy gut microbiome.
And the gut health connection to immunity is huge, right?
Massive. A healthy gut is increasingly seen as central to balanced immune function and lower inflammation. So diet is powerful.
Okay, what about moving our bodies? Does exercise directly fight inflammation?
It absolutely does. Regular physical activity consistently lowers those inflammatory markers like CRP in the blood. It also improves blood vessel health directly. It's probably one of the most potent anti-inflammatory strategies we have access to.
And sleep. I always feel like sleep is the foundation for everything. Is it critical here too?
Critically important. Good quality sleep is absolutely essential for proper immune regulation. If you're chronically sleep deprived, it can definitely push your system towards a more inflammatory state, keeps that alarm system buzzing.
Makes sense. What about stress? That feels unavoidable sometimes.
Well, chronic unmanaged stress is the real problem. It keeps your body in that low-level fight-or-flight mode,
Right.
and that physiological state directly fuels inflammation. So finding effective ways to manage stress, whether it's mindfulness, exercise, hobbies, whatever works for you, isn't just mentally beneficial, it's physically protective.
And I assume the obvious ones, avoiding tobacco, limiting alcohol.
Definitely key. Both tobacco smoke and excessive alcohol directly promote inflammatory pathways in the body. No question about that.
Okay, so there's a lot we can do lifestyle-wise. But how do doctors actually, measure this silent fire? Can they track it?
Yes. Thankfully, there's a relatively common and simple blood test. It measures C-reactive protein, usually called CRP.
CRP, I've heard of that.
It's a general marker of inflammation in the body. Higher levels can indicate ongoing inflammatory activity. It's useful for doctors to help identify that residual inflammatory risk we talked about.
So even if your cholesterol's good, a high CRP might signal there's still an issue.
Exactly. And it can also be useful for tracking progress, seeing if lifestyle changes or medications are actually helping to lower that inflammation level over time. It gives us a bit of a window.
So bringing this all together,
Yeah.
what's the big picture takeaway here? It feels like we're really shifting perspective.
I think we really are. The most exciting part of understanding inflammaging is realizing we're moving beyond just, putting out fires when they erupt.
Reacting to heart attacks.
Right. We're moving towards proactively fireproofing the building our bodies. If we can really get good at combining these new targeted anti-inflammatory treatments when appropriate.
With those powerful lifestyle choices that support immune balance.
Exactly. If we combine those, we're not just protecting the heart anymore. We're actually tackling one of the fundamental processes of aging itself.
And while there's no single anti-aging pill right now,
No magic bullet, no.
it really does sound like taming inflammaging could lead to, healthier hearts, yes, but maybe just healthier, more vibrant lives for longer overall.
That's the hope, building resilience from the inside out.
So here's something to think about. Imagine how much more vibrant, how much more resilient our later years could potentially be if we really started proactively managing this silent fire from within. What steps might you take starting today to help quiet your own body's alarm system?